All right, in this video I'm going to go over factoring complex trinomials. So complex trinomials like ax squared plus bx plus c, where a is not equal to 1. So an example that could be like 3x squared plus 5x plus 7. So that's a complex trinomial. Okay, another one could be 4x squared minus 13x minus 12. So the basic idea is, first of all, we want to look at this number here and this number there. And if we multiply those, we get negative 48. What we want are two numbers that when multiplied equal negative 48, and when added, it's going to equal to negative 13. And then at the end of the video, I'll kind of go over a brief explanation of why this works the way it does. But this is essentially the scheme that we use to solve these problems. So what numbers do that? So 12 times 4, no. 16 times 3? Yes, okay. So it's something like 16 times 3. One of these has to be negative because it has to multiply to negative 48. And when we add them, we get to negative 13. So that tells me that it has to be negative 16 and 3. Okay, so I'm going to rewrite this equation, but I'm going to use these other numbers instead of the negative 13. So 4x squared minus 16x plus 3x minus 12. And we can see that this negative 16 plus 3 is the same as negative 13. All right, now I'm going to treat these as like two different binomials. And I'm going to look for a common factor in each of these. So this first set here within 4x squared minus 16x, there's a common factor of, let's see here, the common factor would be 4x. So I got 4x, and then I'm left with an x there and a minus 4. And then this one, there's a common factor of 3. So I'm going to go 3. And I'm left with an x minus 4. And if you've done everything correct up to now, if you multiplied these two numbers, if you found the two numbers that multiply to it and add to the negative 13, and you factor this correctly, you will get these two binomials that are in red. They will be exactly the same. Okay, so then what else do we do here? Well, this is kind of similar to if I had something like 4x plus 3. If you had this, and I asked you to factor that, I think everybody would agree that there's a common factor of y. So they'd go like this. Well, there's a y, and I'm left with a 4x plus 3. I think most people can see that. And we're going to do the exact same thing here. You can tell my color coding. The red y in this example is exactly like the red x minus 4 in parentheses. I treat them exactly the same way. They are a common factor. So I'm going to pull out that common factor, x minus 4. And in this one, when I pull out the common factor of x minus 4, I'm left with a 4x. And in this one, when I pull out the common factor of x minus 4, I'm left with a plus 3. And there you have it. That is how you'd factor 4x squared minus 13x minus 12. So that goes there, that goes there. And we can double check, we can expand it again. Maybe I'll expand it in green. So I'll foil this. X times 4x is 4x squared. X times 3 is positive 3x. Negative 4 times 4x is negative 16x. And negative 4 and negative 12. And sure enough, that works. Let's try another one. Okay, let's do 12x squared minus 2x minus 4. Okay, rule number 1, common factor. There's a common factor of 2 in here, so let's factor that out. So that's like 6x squared minus, we can call it 1x minus 2. Alrighty, next step is I need two numbers when multiply equal 6 times negative 2, so negative 12. And when we add those two numbers, we get negative 1. So when they add a negative 1, they have to be pretty close together. So those numbers would be 4 and 3. One of them has to be negative. And since when we add them together, it's negative 1, that means the bigger one is negative. So those are our two numbers. Okay, so let's do this. We got to keep the 2 there, but we don't have to do much with it right now. So we could do 6x squared plus 3x minus 4x minus 2. That's one way to do it. So instead of doing negative 1x, I'm doing 3x minus 4. There's another way we could do it as well, and that's 2 times 6x squared minus 4x plus 3x minus 2. And I would argue this is actually a little bit easier, and I'll show you why in just a second. But generally speaking, if you have two numbers and one is a negative, putting the negative one as first is a little bit helpful. Okay, but let's continue with this one. So 2 times the common factor with 6x squared plus 3x, that would be a 3x. So 3x and 2x plus 1. Now the common factor with 4x and 2 is 2, so I could go like plus 2. And that leaves me with a negative 2x and a minus 1. And that's kind of weird. This is the weird part. That is not the same as that. They're really similar, but kind of different. And I said earlier, you have to make them so they're the same. So really what you have to do is you have to rewrite this like... So that part is fine. But instead of going plus 2, I'm going to go minus 2. And that'll make this a 2x plus 1. And now we can see we have a common factor. So my common factor is 2x plus 1. And that leaves me with factoring out a 3x minus a 2. And there we go. So that works. It's fine. It's okay. But if we put the negative one first, we kind of avoid a little bit of that. So I'm going to do this one. So 2, it's common factor with 6x squared, and 4x is 2x. So that leaves me with a 3x minus 2. And then common factor with 3x minus 2, the common factor is 1. So it's 3x minus 2. And now I can pull up my common factor here. So 3x minus 2. There's one there, one there. And I'm left with the 2x plus 1. And we get the same answer. But I would argue this is just a little bit less confusing. Not much, but a little bit less confusing. I think we should try one more. Let's do 3x squared minus 5x plus 2. Okay, so looking for two numbers. Multiply to 3 times 2. So multiply to 6. Add to negative 5. So if they're adding to negative, but they multiply to a positive, it means there's two negative numbers, and I'm guessing it's just negative 3 and negative 5. So those are our two numbers, m and n. Okay, so 3x squared. They're both negative, so it doesn't matter the order. So I'll just do it like this. Then I'll look at these first two. Common factor is 3x. And then now we'll have to deal with the negative sign. So I want the x term to be positive, so I'm going to make this a minus. So there's a common factor of 2. So that is an x minus 1. Now we can do our common factor of x minus 1 and leaves us with a 3x minus 2. There you go. That will be 3x squared minus 5x plus 2 all factored. All right, lastly, I can go over a brief explanation why this works, this method. We have an ax squared plus bx plus c, and it factors to something like this. So these two numbers then, the numbers, so let's look at what a is. Little a is equal to a times c. And c, little c, is equal to b times d. Oops, let's make that a little bit nicer. So I'm just, like, I know the x squared term is the big A times the big C, and I know this term, the little c, does not have an x in it. It has to be the b times d. So that's where these come from. We also know that b is made up of the other two. So b is equal to AD plus BC. Okay, so these are in fact the two numbers that we're looking for. Like b is equal to like this m plus n idea, where m is AD and n is equal to BC. And we can check that with this first step we always do is we multiply the first and last term, so the AC. So we're saying that AC is equal to mn. And AC, little a is capital A, capital C. And little c is b times d. And sure enough, that's equal to m, which is AD, times n, which is BC. They're just rearranged, but it's ABCD, ABCD. So that's kind of like a proof as to why that works. Alrighty, there you go. Good luck.